Your textbook actually continues to simulate to t equal to 20 with 3 more events. This is left to you as your assignment. We have a table to summarize the final statistical accumulators. From the manual simulation process, we found out this is well suited to standard programming. It is a step-by-step procedure. The simulation process we just went through is only one replication, that is, one sample. Usually, in computer simulation, we need to do many rounds of simulation and collect the average output to smooth out randomness in the output results. In computer simulation, instead of specifying the parameters as fixed values, it is often more convenient and reasonable to assume that the parameters follow some probability distribution with then sample values from the probability distributions. With sampled inter-arrival and surface time values from probability distributions, we can make multiple rounds of simulation. Here we are showing the results for 5 replication rounds. We can calculate the average values and the standard deviations for the average values. With average values and a standard deviation, we can calculate the confidence interval for each statistical accumulators. We have learned that the student T's distribution from INEN 3322 probability and statistics. The concept of confidence interval is in INEN 4320 statistical decision making. We assume that individual replication results are independent and identically distributed IID. We can improve precision by running more replications. In the previous simulation, we used the same probability distribution for all replications. During the investigation, we often want to change the parameters for the probability distributions to test alternatives. For example, what if we double the arrival rate? We can run another 5 replications to see the new output. This figure compares the original and double time arrivals. We should not draw conclusions based on only one replication. We need to run multiple times and compare results statistically. In this slide, we illustrate how we calculate the confidence interval of the average waiting time for the original problem. This slide shows how we can calculate the confidence interval of the average waiting time for the new problem. We need to run a t-test to find out whether the two results are statistically different. Alternatively, we can compare the confidence intervals, and if they overlap, based on this analysis, we cannot say there is a statistical difference. In the next slide, we will try a different way to test the statistical difference. This is another way to compare the two results. We can pair the values in each replication and find a difference. The 95 confidence level is 0.51 to 4.43. This interval does not span 0. Since this interval does not span 0, we can say the waiting time for the double time model is statistically greater than that in the original model. Therefore, this is a better way of comparing the two parameter settings of the same model. In this lecture, we learn concepts and terminologies through a manual simulation process. You may also have realized that probability and statistics are critical to the analysis of simulation results. This is the assignment.